Test.
Are we on?
All right. All right, we'll go ahead and get started. It's a quarter to 12. I'd like to just welcome everybody to the session. Good afternoon. My name's Craig Kitterman. I'm a senior technical product manager, or actually senior product marketing manager. It's my new title in Windows Azure marketing. And I'm joined here by my colleague Adam. Let him introduce himself.
So my name's Adam Hall. I sit in the Windows Server and marketing team. So System Center and Windows Server sit under us. So Craig and I are going to jointly present these parts 1 and parts 2. And Craig's going to cover from a Windows Azure perspective what that looks like. And then I'm going to show you what that looks like from a System Center point of view to give you both views of these two different worlds and how they come together.
Great. Thanks, Adam. So what I want to do today to start out is just do a sort of crash course on Windows Azure, just to make sure everyone's sort of on the same page. But before I do that, quick survey of the room. How many of you attended my session yesterday, the Windows Azure Overview session? Okay, so maybe a dozen. So you folks are going to be kind of bored for the first 10 minutes, and I apologize for that, but I really do want to make sure everyone is on the same page. I'm going to move through the content pretty quickly. If you have a question, don't hesitate to interrupt me. No problem answering questions in the middle. I want to make sure everyone understands what's happening and we don't go through this too quickly. But I want to go through pretty quickly so we can get to the interesting bit, which is the System Center integration, the management and monitoring piece, which is probably most interesting. So just a quick level set on, when we talk about cloud, obviously there's a lot of buzz around cloud, and there's a lot of people using cloud in many different contexts. And I just want to set the stage for what Windows Azure is and sort of where we play in the context of the continuum of cloud services. So we have this sort of notion of 3 different types of services that are offered in the cloud. The first one's infrastructure as a service. This is basically raw VMs that live on in somebody else's data center that you control and manage sort of everything from the OS on up through the middleware. And just the hypervisor on down is managed by a vendor. So you have full control over those virtual machines. The second type, and this is where Windows Azure plays today primarily, is in platform as a service. And platform as a service is a little bit of a different model. You can think of it to some degree as an application container. You take your code and you push it to Windows Azure, and Windows Azure just runs that code. You don't have to think about the operating system. You don't have to think about patching and managing security updates. All of that is abstracted away from you, and you're really just concerned about the app. And you have a very app-centric point of view when you're looking at platform as a service. And of course, at the far end of the continuum is software as a service, and this is something like Salesforce or something that's just delivered to an end customer, primarily delivered in a very multi-tenanted type of environment with many users consuming the same physical resources. So we're going to talk sort of about the middle one in platform as a service. So what is Windows Azure? It's a comprehensive, multi-purpose cloud computing platform. That doesn't really mean a lot, except to say it's a place you can run apps. And you can run just about any type of app in Windows Azure. If it will run on Windows Server today, you can run it in Windows Azure. There's different configuration steps and startup scripts and stuff that may need to be written if you have a very complex configuration. But in a nutshell, you can run anything in Windows Azure that you can run on-premise or on a Windows Server today. The Windows Azure platform gives you that sort of compute capability, and I'll talk in just a minute about some of the other capabilities of the platform. It also gives you a little bit of management and monitoring capability through the Windows Azure portal. And of course, why would you want to do that? Really, the key benefits of Azure are all about scalability. Scalability, scalability, scalability. Availability and fault tolerance. Okay? So think about those things in terms of various types of traffic patterns that your applications receive. So cloud, and in particular public cloud, is sort of optimized for these types of traffic patterns. You probably recognize these. On and off is a really common scenario when you have big jobs that you want to run, big batch processes or something, maybe in the middle of the night, and then you want to shut that off. So it's something that just runs for a short period of time and it's off. Another scenario would be a short-lived type of marketing campaign that's up for a few days or a few weeks, and then you want to shut that off. So rather than building out infrastructure, buying servers and infrastructure for the worst-case scenario, you can simply use the infrastructure when you need it and then turn it off. Growing fast, This is a pretty common pattern for small businesses that don't really know the future, but they start to take off and have some early success, and all of a sudden their traffic sort of spikes. Unpredictable bursting is otherwise known as the Slashdot effect. Something happened, and all of a sudden there's an unplanned influx of traffic to your application or your website, and you need to be able to manage that. And the last one is predictable bursting. This is the Super Bowl Domino's Pizza scenario. Domino's Pizza knows that more people order pizza on the day of the Super Bowl than any other day of the year. So they have the ability the night before the Super Bowl to go spin up a bunch of extra capacity in the public cloud to absorb that traffic, which they know is going to come as soon as or just a few hours prior to kickoff. So these are the types of scenarios, and you notice the thing that's constant here is variability. If you have a consistent set of traffic to your application, you can do resource planning in a very simple and straightforward way. But if you don't, and your traffic sort of looks like any of these for any particular application, you may want to consider more on-demand, scalable type of resources that you can throw out a problem when it's needed, and then shut those things back down. So Windows Azure contains sort of three core services. Compute. This is actually those containers that I talked about where you put code and it runs your code. Very simple, compute. Storage. We have a very, very big, highly scalable, globally redundant storage system that is analogous to Amazon S3, if any of you are using S3 today. And we have a relational database as a service. And this can be thought of as SQL Server in the cloud. This is a multi-tenanted database service which is exposed to you as a logical server. So very easily you can go into the Windows Azure portal, provision a new virtual server, provision a new database, and grab a connection string, drop that into your existing SQL Server management tools, and that database server will show up to your management tools in the same way a regular physical or virtual SQL Server shows up. So it's manifested in the cloud as a sort of virtual server. And it speaks the same TDS protocol of all the other SQL tools, so you interact with it in the same way you do an on-premise server. But you get a lot of interesting things like scalability, redundancy, and all of that for free. So let's drill in just a little bit to compute so I can explain to you how the actual services are laid out in Windows Azure. And there's a little bit of a hierarchy here. So the first thing that you create in Windows Azure when you're going to go put an application up there is something called a service. And a service is basically just that container for an application. So for every application, you'll create a service. So you can think about it that way. A service, however, can contain multiple roles. And you can think about roles as being virtual machines that are doing something. We have a couple different role types, which I'll show you in a minute, that can do different types of tasks. But at the end of the day, when those actually get instantiated in Windows Azure, although you don't care about the details of the virtual machine and all you care about is that application container, each of these roles represents a virtual machine that's running in the cloud. And finally, instances. So instances are just that, instances of those roles, those virtual machines, that are imaged in the exact same way. So if you have an application package that gets installed and it has a couple of roles in it, and let's say you hit one of those big traffic bursts, unknown or known spike in traffic, you have the ability to scale that application out into multiple instances. And basically what the Windows Azure Fabric will do is it'll create exact replica copies of those virtual machines and then load balance those. And I'll show you how that actually works in just a moment. So I mentioned there's a couple different role types. These are the different type of compute things that you can put into the cloud. So the first one is web role. This is analogous to any kind of application that will run on IIS today you would put inside of a web role. You can think of it as a virtual machine that's sort of already set up and configured and optimized to run web code. That's all a web role is. So when you create a web role, you simply stick your ASP.NET or whatever code you're going to run on IIS, and it goes in there, and Windows Azure will instantiate a virtual machine, configure it properly, run your code. A worker role is simply an executable. You can think about this similar to how you think about Windows services. It's doing some asynchronous background type of processing. A common pattern nowadays is to have an application that has a web role and a worker role in it. The web role will queue up work using Windows Azure Storage in the queue system, and the worker role will come up later and pick up that queue item and go do something. So an example of this would be if I need to reset my password on the website, and let's say there's a bunch of processes that need to happen in order for that password reset to take place. Rather than waiting on the web thread to go do all that and then coming back to the user and saying, okay, your password's been reset, the web role will simply drop an item on the queue, say, hey, worker role, go take care of this, and then it'll come back to the user and say, expect an email in a few minutes and your password will be reset. And then the worker role can come along later and sort of pick that up. And last but not least is a VM role. This is basically a fancy worker role that allows you to configure the virtual machine exactly how you want it, and then upload that VHD file, your virtual hard disk file, to Windows Azure, so you have a sort of pre-canned custom configuration for a role that you want to run in Windows Azure. This is pretty commonly used by our customers who are doing large sort of high-performance computing or parallel applications that require some custom software packages that they don't want to script in a worker role, in a startup script in a worker role, and they want to just have ready to go and pre-configured. Okay, so that's the basics. Windows Azure Storage, I talked about it. It's a multi-redundant system. You have, by default, anytime you store something in Windows Azure Storage, you get automatically 3 copies of that data replicated elsewhere in the system. So if there's a hardware failure and you lose one of those instances, you automatically have 2 more. And as soon as Windows Azure recognizes the hardware failure, it will spin up other capacity and make a new replica copy. So you always have 3 replicas. And all that you get for free just by using Windows Azure Storage. It's optimized for speed and availability. And there's sort of 4 different types of storage mechanisms in Windows Azure. Blobs, which is just any arbitrary binary data. You can think of this as a file system in the sky. Tables is simple key value store. And queues, as I mentioned before with the web worker scenario, it's just a place to put very simple messages as a non-transactional queue-based system. And last but not least, we have something called Windows Azure Drives, which is useful in certain scenarios where you can actually mount a virtual hard disk, a VHD, that's sitting in your Windows Azure Blob storage account. You can mount that in one of your virtual machines as an NTFS file store, so you can read and write and persist data to a blob. So that's the storage in a nutshell. SQL Azure database, I already kind of talked about it. It's optimized for fault tolerance and availability. And it's very inexpensive and easy to get up and running. So a lot of people are using SQL Azure databases for production application workloads, but they're also using it for disaster recovery purposes and replicating certain pieces of data out to the cloud that need to be consumed by other B2B type applications. So it's an interesting way to augment your existing SQL Server infrastructure. So where is Windows Azure? That's what I get people asked that all the time. How do I run it? Where do I put it? What is it? Well, Windows Azure is actually running in Microsoft's data centers. These are wholly owned data centers run by Microsoft IT and Global Foundation Services. And we have 6 of them around the world today. 2 in the US, 2 in Europe, and 2 in Asia. And I actually think there's a 3rd one in North America that's either online or coming online very soon. And what that means is that you can run your code in any one of these data centers. It's up to you. If you have customers who are distributed around the world, you may want that code actually be closer to those users and running in data centers that are closer to those users. In addition to these 6 data centers that I have listed here, we also have our own CDN service, our own content delivery network service that's part of the Windows Azure platform. And we have 26 CDN nodes around the world. So you can actually cache all of your static content, images, graphics, videos, and the like in those CDN nodes. So regardless of where your customers are coming from around the world, they're going to get a great low latency experience with that content because it's going to hit the nearest CDN node to the user to serve up that content. So we have some connectivity options in terms of, today we're talking about sort of the hybrid story in terms of how does Windows Azure fit into existing on-premise infrastructure, and how do we sort of think about building applications and services that consume in the right ways public cloud and private cloud. So there's a few different ways that we look at connectivity between these two. The first one is data synchronization. There's some easy tooling to allow you to synchronize data from on-premise SQL servers up into SQL Azure. It's one of the scenarios I mentioned before. Application layer connectivity and messaging. There's a Windows Azure service called Service Bus, which is a more transactional-based queuing system that gives you the ability to have sort of a common messaging layer between your on-premise applications and workflows and things that are running in the cloud. So it's very easy to share information and messages between those services and stitch things together in a logical way. And last but not least is we have something that provides secure machine-to-machine connectivity. So let's say you want to build an application that your customers or your partners are going to consume in the public cloud, but you need access to a server or a database that's back in your on-premise network. With Windows Azure Connect, you have the ability to actually set that up by simply installing an agent on that on-premise machine, and that will create a secure IPsec connection with your cloud application, so your cloud application can actually get through the firewall and access the data on that machine. And in the future, we've already announced that in the future we will have something called, I don't know what it's going to be called, but it's site-to-site connectivity. And this will allow you to literally have share network space between your on-premise network and the cloud, so you can actually interact with machines directly through a VPN connection of some kind. So this is coming at some point in the future. So when we think about what do we have available for IT pros to sort of play with and look at Windows Azure, first of all, PowerShell, of course, is an important tool set in interacting and managing Windows Azure and Windows Azure applications. What we've done in designing Windows Azure is we've built an API layer that all of the other actual first-party Windows Azure services consume to expose things through, let's say, the management API. So when you log into the Windows Azure website and you go to deploy an application or monitor or manage something, what you're seeing is a website that's actually using an API to get at that data. And that's the same API that you have access to programmatically from any other piece of software or from the PowerShell scripts. And the reason that we do that is just to make sure that we're doing the right things in the API, exposing the right things. And the nice bit of that is we've gone ahead and created a set of PowerShell commandlets that really have access to that entire breadth of the API. And you can do anything you can do through any of the other Windows Azure interfaces, you can now do using PowerShell commandlets. And I can show you a little example of that. And if you want to see more, you can come by the Windows Azure booth, and I'll show you how that works. Remote desktop. You have the ability today with any of these Windows Azure roles to configure remote desktop. Now, in a sort of a perfect past world, you should never need to do that, right? Everything should just work. But we've learned from our customers that people, every once in a while, if something's not going right, they just want to get on the VM. They want to get on the thing, look at the event log, understands what's happening, look at the configuration, and just try to troubleshoot. And so we've enabled remote desktop so you can do that kind of troubleshooting and really dig in and see what's happening on your virtual machine. We have the sort of Windows Azure server tools and, of course, the Windows Server system tools and, of course, the System Center tools that we'll look at in a little bit. So interacting with Windows Azure from an IT point of view is really you're doing things in a different way, but you're still doing the same things that you've always done. And so what I want to show you right now is what the deployment process actually looks like inside of Windows Azure so you can understand what's happening under the covers in the cloud when an application actually gets deployed. So a Windows Azure application starts as something called a service package. And a service package is nothing more than a glorified zip file. And what it contains is the code for your application and a manifest with some other information about how the file is structured and what's inside there. And then there's a second file that also comes with your application, and that's a config file. And so when your developer comes to you and says, okay, here's my application, it's ready to deploy, your developer is going to come to you with two files, a CS package and a CSCFG. So one is the application code, and one is the config file. And those are the two units that you will actually use to go push into the cloud. So once you have that service package, you simply upload that to the cloud. There's a few different ways to do that. If developers are deploying directly to the cloud, they're probably going to use Visual Studio. And I'm going to show you what that looks like, even though I know most of you probably don't use Visual Studio. I want to show you what that looks like from the developer point of view. You can also take those two files. You can upload those through the Windows Azure portal, which is just a web interface. You literally just browse and upload the files. Or the third way is with App Controller, and Adam's going to show you that in a little bit. So once that file is uploaded into Windows Azure, Windows Azure looks at the configuration file and says, okay, this application is asking for two virtual machines, two roles. Okay, so I'm going to go ahead and look around my Windows Azure Data Center and find two virtual machines that, a rack of servers that has a couple virtual machines available to it. And I'm going to go ahead and boot those things up. Then I'm going to put them online in the Windows Azure Fabric. Okay? So now those virtual machines are up and running. They have Windows on them and sort of the base Windows Azure OS install. And then the system pushes that code. So it grabs the code out of that package file that you uploaded, and it installs the code on those virtual machines that have been automatically provisioned for you. Once it's done that, it configures network load balancing across those instances. So actually, in this case, it's not 2 roles. It's 1 role that has 2 instances. So think about this just as a website. Let's say our application was just a simple website. But I know that my application is going to receive a lot of traffic, and I also want to have the full Windows Azure SLA, so I'm going to deploy 2 instances of that application. So as soon as those are spun up and the code is installed, Windows Azure automatically configures network load balancing across those 2 instances once they're up and running. Now, the nice thing about Windows Azure, as I mentioned before, it's built for scalability. In fact, virtually infinite scalability. So if you decide that one day, okay, I just got Slashdotted or we're on Oprah's Favorite Things, and 2 instances just simply isn't going to cut it, you go and you change a number in the Windows Azure configuration and scale up to 6. Windows Azure goes through that same process, imaging those machines, installing the code, and setting up the load balancer across 6. Okay, well, now you just made CNN and a few other things, and you realize 6 is not going to do it either, so I need a lot more. So now I'm going to scale up to 92. Well, in about 5 to 8 minutes, you're now going to have 92 load balanced instances of your application, and that's going to be automatically provisioned and imaged and managed for you in the Windows Azure Fabric. Okay? Now, the next day, you're not cool anymore, and everything sort of, all the news cycle dies down, and you need to go back down. No problem. You simply change that number and go back down to some other number. In this case, 10. So you have a few new customers who are going to regularly visit you, but the hype's gone. So we're going to go from our original 6, and now we're going to be 10. And that's going to be probably what we need for the next little bit. So you simply scale that back down to 10. No problem. It's a change of a number and a few minutes of waiting, and your application is scaled back down. And the best part is you only pay for what you use. So you're only paying while those applications are running on those virtual machines, and as soon as you turn them off, it's over, okay? So now if you want to update the application, this is what the update process looks like. Now, because I have 2 instances of my application, what Windows Azure automatically does is it puts those things in 2 different upgrade domains. And so what that means is it won't take both instances of the application offline for the update. So what it does is it takes one off the load balancer, updates the code on that one, and then puts it back in the rotation. And then after that's done, it does the same thing with the second virtual machine. A very similar process takes place when Windows Azure actually updates the underlying OS and bits on the machine. So as I mentioned before, with Platform as a Service, you don't need to think about security updates and all the sort of low-level OS stuff that you typically work with. And that's because Microsoft does that for you. So on occasion, Microsoft needs to update the OS and do some service packs and whatnot on the underlying OS that's running on these virtual machines. So when you have more than one instance, Windows Azure has the ability to do that without disrupting your application. So there's another concept here which is pretty useful. When you have a Windows Azure hosted service, you get by default 2 containers to put your application in. One of them is a production container, and one of them is a staging container. And when you deploy, you have the option, and I'll show you this. Do you want to deploy this one to your production container, or do you want to deploy this to your staging container? And what that gives you the ability to do is to deploy your application, get it up and running, and test it and play with it and sort of do your standard smoke tests and make sure everything's cool before you put it into production. So when you provision an application that has a web endpoint, like let's say a website, you get a DNS name. Windows Azure gives you a DNS name, myappfoo@cloudapp.net, and then you can alias that with CNAMEs and whatnot. And then when you deploy a staging app, you also get a DNS name, but instead of myappfoo.cloudapp.net, it's someguid.cloudapp.net. And that allows the developer or the application deployment manager to access that application and run whatever tests on the app that they need to run before rolling that into production in sort of a private URL that nobody else knows about. Once you've gone through that smoke testing and you understand that everything looks good and it's working, you simply do what's called a virtual IP swap. And this is literally one button in the Windows Azure portal or a PowerShell command to do that BIP swap and say, what's in staging now, I want to go into production and be associated with that real DNS name. And what's in production, I want to go into staging. So you do that swap, and instantaneously, or over the course of a few seconds, you get a clean swap of those environments. If you now are running what was in staging is now in production, the load balancer is pointing to the right bits, everything's going fine, you realize, uh-oh, a few hours later there's a bug in the code that we didn't realize in our smoke, we didn't catch it in our smoke test or whatever. You can simply click that BIP swap button again, and what was in production before goes back into production, and then you can go troubleshoot and redeploy back into your staging container. So it's a sort of nice way to move things into the cloud without disrupting your existing users and really get a good real test is how is this application going to behave when we set it up. So I mentioned a little bit about upgrade domains and this notion of sort of a rolling upgrade that gives you high availability. So when you do an upgrade, you want to make sure that at least one or more instances of my application is still running while the upgrade is happening. And that's what we call an upgrade domain. We also have the notion of a fault domain, and this is basically keeping instances of the application on separate fault things that can fail, let's put it that way. So in the case of our fault domains, it's primarily like a server rack. So if a single server rack has a single network source, a single power source, you want to make sure that your application is running across two of those failure zones. So that if we have a power failure or a network failure on one rack, you know that you're going to have a continually running instance on another rack. As soon as Windows Azure recognizes that failure, it's going to create another instance of your application on another working rack and then fix the load balancing to automatically bring that one up online. So you can sort of visualize here, upgrade domains can be between fault domains, and fault domains are sort of these vertical units of failure, power, network, etc. So I'm going to show you now just a quick demo of what a Windows Azure application actually looks like from a code point of view and what developers would do if they wanted to deploy the application. Then I'll show you quickly another way to deploy the application using the Windows Azure portal, which is what you might want to use as an IT professional to deploy that application. And then Adam's going to show you the best way to do it using App Controller after I'm done. So
the good news is that's basically all the slides for this session and the next session as well. We're all demo from now on. Okay, so that's
sorry to bore you to death with the slides, but I just want to make sure everyone was on the same page here.
So we are running live here as well, so hopefully the internet holds up okay.
Okay, so what I have here, for those of you who aren't super familiar with Visual Studio, I have a very simple application. It's got a single worker role. So remember I mentioned the different units of compute. This is just a single worker role, which is nothing more in the code here than a run loop. It just runs forever while true and does some stuff. That's all it is, okay? In reality, I would put something like, hey, go check the queue and run some email password reset operations or whatnot, and then go to sleep for 10 seconds and then wake up and try it again. That's sort of what you would run in a run loop. The other thing I have here, which makes this not just a simple Windows service, but actually a cloud application, is a set of configuration data that tells Visual Studio this is not just a regular app, this is a cloud app, so treat it as such. And when I run the application, it's going to run in a simulated cloud environment on my machine. And when I go to deploy the app, it knows it's a Windows Azure app, and so it knows it needs to do some different things when I try to deploy. So I have this simple app, and basically, first thing I'm going to do is just package my app. So that does a build on my app, and it's going to pop up and say, okay, here's your cloud package. This thing's ready to go. So I mentioned before, at the end of the day, you're going to get two files. You're going to get a package file and a config file, and that's what we have here. So Windows Azure created those for me. It bundled up all of the code for my app, all the relevant dependencies, all the DLLs, and put them in these package formats. So in this case, I would hand off as a developer to my IT professional who manages deployment and say, here's my app, it's ready to go. So you would take these two files, and then you would go to the Windows Azure portal, and I will log in very quickly to the Windows Azure portal. And normally you do this with a live ID, but because I'm using a Microsoft account, I unfortunately have to use my Microsoft credentials.
How many people have Windows Azure applications running today?
Okay, all right, well, I can't log in right now. They just changed my password. So let me show you the Visual Studio way to deploy apps that typically a developer will use. So they'll right-click on that cloud configuration project and say, okay, I want to publish this app. And so it says, okay, we have a few registered subscriptions here. Which one do you want to use? I'll pick the subscription I'd like to use. Then it's going out to Windows Azure, and with the certificate that I've already exchanged between the Windows Azure portal and Visual Studio, it's authenticating me and saying, okay, here's all the hosted services that you already have running in the cloud. Do you want to deploy to one of those, or do you want to create a new one? And I'm just going to go ahead and create a new one, and we'll call it MMS Demo. And I don't care where you deploy my code. Go ahead and deploy directly to production, and that's the configuration that I want, and then I just click Publish. And then Visual Studio goes out, and through that Service Management API, it goes and deploys the code for me. All right, so what I'll do now is I'll hand it over to Adam, and he can show you the app controller piece. And while he's doing that, I'll try to get the web upload working so I can show you the other way to do it, which is a little bit simpler and easier.
Nice. Okay, so was everyone in the keynote this morning? Anyone not in the keynote this morning? A couple. So we showed App Controller. Ryan showed App Controller on stage, deploying applications and engaging with the different clouds. So this is the same keynote environment, slightly different user, a little more verbose. We have a lot more information here. Now, we talked about the managing across the clouds, and in this particular environment, we have those two clouds that Ryan showed on stage this morning, and we have a Windows Azure subscription loaded here as well. Inside that Windows Azure subscription, we already have one service running. You can see we get the tile layout back. Now, you'll see up there's a couple of different formats. I've deliberately stopped one of the services to show you what happens. As an application owner, I don't need to get into the detail, but I do want to know, is everything okay with my applications? So the intranet servers underneath, I have stopped that server so you can see what it looks like, but it allows me to drill in and see what's actually going on. If I bring up this view, which actually I'll bring up the full one. System's running a little slow. Here we go. So as I bring that up, you can see that I have stopped the underlying virtual machines inside that service. I can see that that's what the problem is. I can talk to my data center admin, work out what's going on. But just to show you have the different processes coming through. Those Windows Azure subscriptions and the applications that are running, as Craig talked about, you get a very similar diagrammatic view here. Craig talked about the different roles and the different instances that are here. In this very simple application, we have a hosted service running, and we have configured our public URL. We've deployed to the Southeast Asia region, and we can configure all of those different pieces of information inside App Controller as well. I'm looking at one that's already deployed. I'm going to show you what it looks like to deploy a new one as well. You can see Craig talked about the underlying operating system and the way Windows Azure takes care of all that patching and maintenance for it. I know that this was certainly not the guest that I deployed. You can see all the different ones that have been updated. You can see the dates when they are updated. Okay? So as a new operating system comes out, you have the ability to roll from one to the other. The upgrade domains kick in, and they deploy the new versions of the app. In a cloud context, and whether that is in a private cloud and on-premises, whether that is in a hoster infrastructure as a service, whether that is in Windows Azure Platform as a service, the updating of the underlying operating system changes a lot. And the ability we have to uplift the applications, update the underlying operating system and so on, allows us to get that high availability, allows us to have that scalability and really bring back, there's no downtime. You don't need to install a patch and reboot the server. And a lot of the sessions that I'm in this week talking about this will show you how we achieve that. How do we move away from patching servers where you have to install something, shut it down, bring it back up to bring the app back online? Being able to move to app virtualization, to move to this model where you can update the underlying operating system through upgrade domains, and through that brings around the high availability and brings about that scalability. And then within the roles themselves, Craig talked about the scale. I'll show you what that looks like. In App Controller, we have the instances there. So this is a very simple role. It's got 1. I can crank that out to 2, click OK, and say, yes, I want to update that. What you'll see is that App Controller is now talking to the service bus that Craig talked about. Everything in System Center that I'm going to show you in the next or the rest of this session and the next session are all talking to that Windows Azure API through the service bus. It is all doing it through that one common interface. Whether it's App Controller, whether it's Operations Manager, the same subscription and certificate-based authentication applies. So that's now scaling out. Usually takes, as Craig says, 5 to 8 minutes. It'll roll that out. That'll finish throughout the demo. But how do we get to this point? App Controller allows you to do the management of underlying libraries of applications as well, both for on-premises services and virtual machines that you've deployed, but also for Windows Azure. So we've configured a very simple file share here, and we've put a couple of an application, a Windows Azure hosted service here. This is the package and configuration file that Craig created earlier. I can pick those up. And if you don't have developers publishing directly to Windows Azure, which you probably want to get in the middle of that to put some control and authentication around that, pick up those 2 files and simply copy them. I can now go up to Windows Azure and take a look at that subscription that I've got access to. You can see I have a few folders there. I'll create a new container, and we'll just call that MMS, and it has to be lowercase. It's, again, going to go through that API. It's running the commands against Windows Azure to create a new container up in Windows Azure under that subscription. It takes a couple of seconds to come back. It's completed. Go into that container, and here's the hierarchy that Craig was talking about for the virtual machines, but also in the storage repository as well. So we'll create that and click Paste. This is the blob storage that Craig talked about, any binary file. I've just taken that package and configuration file off a standard file share on Windows Server, pasted it up to Windows Azure, and it's now uploading it. The first file is up. Second one will be there pretty shortly. I get a notification that it's complete. I think the second one's a little bit larger. I'm not sure how fast the internet is from here at the moment. Let's see, has it come back? Yep. Give it a sec to upload. There we go, 3 meg file, so it took a couple of seconds to upload. So I've now taken those files off my developer from a file share, copied it up to Windows Azure, and I can go deploy that.
So right now, Windows Azure doesn't know anything about these. They're just regular files in your blob storage.
So it's a blob storage inside my Azure subscription. As far as Azure is concerned, it's just a binary file sitting there. It doesn't know what to do
with them just yet, right?
So in order to deploy the application, we come into App Controller again, into the services view. The first thing we're asked for is, where do I want to deploy this application, this service? I could have multiple Windows Azure subscriptions. One of the things that App Controller does for us is take multiple subscriptions, bring them together, and allow me to delegate out who internally gets access to those subscriptions in both a read-only and a read-write way. Okay, I've got another environment where I'll show you I've got lots of subscriptions going and what that looks like. But it provides me the ability to do that. We can choose our Azure subscription. It's an Azure Cloud. And now we've got that same information being asked for that Craig showed you from Visual Studio. We're asked for the hosted service. Do we want to pick one of the existing ones that we've already got, in which case we've only got one, or we can create a new one. So we'll create a new one as well. We'll call it MMS, public URL, MMS, PerfApp. Don't think that one's been used. Southeast Asia is fine. We can take a look at the details, the location, no problem. We're all good there. That will, again, create that public URL. It's checking to make sure it doesn't exist. If you type one that already exists, it's going to come back. And actually, here's a good warning. We've got a Windows Azure subscription that has a limit on it. Okay, so it's actually come back and said, sorry, you're only allowed one instance of the app. So I've been locked down, and I can't deploy that app here. So that's actually a good point for me to jump over to the other demo environment, which has got far more capacity. So in this there's that update. You can see it's come down to this instance. This is actually a completely different environment. You can see that update is coming down. We're scaling out the application. So I have four different Azure subscriptions here. We've got a development, a prod, a staging, and that PCI one that you saw earlier. The way that this is set up, if I sign out, I will sign in as administrator and show you how I configure those. And our lovely, oops, if I could spell would help. So App Controller understands the concept of roles as well. So I have multiple roles within my private cloud. I'm going to log in as administrator. And here I'm going to be able to see all of those connections. So we have 2 connections to 2 different private clouds, Virtual Machine Manager clouds. And under subscriptions, you can see there are the different ones that we have. 3 things are required to connect to a Windows Azure subscription in App Controller. The subscription ID, the certificate to talk to Windows Azure, and the password associated with that. That's it. If you have those 3 pieces of information, you can connect it up. And to do that, you simply click Add, give it a name, paste your subscription ID, browse to your management certificate, and the password. Okay? I'll show you in a slide how we do that certificate management as well. We also have a concept of user roles. And so from an access point of view, you can create different roles to give different people access to different subscriptions. So when I create a role, we'll just call it MMS, first give it a name, whether it's read-only or read-write. Okay? So you may want to give someone access to see all of these and be able to give them only read access. Who do you want to give access to? We can give our Contoso/cloud user account. Add that in. It's going to check that it's a real account. And then it says, which Azure subscriptions does this group have access to? So we could just say that we only want to have access to development and that PCI one, and we'll make it read-only as well. Click OK. It's going to create that role. This information is stored in the App Controller database. Okay? I get a lot of questions, and we certainly had this through the early adopter program. When you install App Controller, what's stored in App Controller and what's stored everywhere else? This is the one thing that is stored in the App Controller database. Everything else is App Controller talking to another repository. It's talking to Windows Azure. It's talking to Virtual Machine Manager. The user roles and the Windows Azure subscriptions are the only things that are inside the App Controller database that are nowhere else. They're not stored anywhere else. So I've just created that user role. I will sign out. If we log in as Contoso Cloud user now, Cloud Sewer, we are in America. And now, under Windows Azure, we have that MMS role that was created. Okay, so I have access to multiple roles as I've built them out through demo. Typically, I'd only have access to one. I click OK. Now, when I go to my Clouds view, I will only see the Azure Development and the window and the PCI. Even more so, if I go and take a look at the services that are running out in Windows Azure and take a look at, why did I double click? Take a look at the diagram view, I can see I've got a couple of roles running here. If I try and change something, that's grayed out. I cannot change it. Okay? It's a read-only role. So giving people access to your Windows Azure subscriptions, letting them see what's running out there, see how they're functioning, making sure they're up, and managing them in a read-only fashion. Okay? Gives you the best of both worlds. Okay. I will just log back in with an account that has a write opportunity. Instead of MMS, let's go in with Azure Access. All right. So, again, we have those same package and config files. I believe we've got them staged already. We'll go and deploy. Oh. Let's choose the Windows Azure Development Cloud. It's going to say, are you sure? Of course I'm sure. Okay, hosted configuration. Let's go with a new one. MMS perf. Western Europe this time, sounds good. I'll create that. It's going to go out, check and make sure. Oh, wow, we're really filling out. Okay, let's go with, I've been doing too many demos. Are you sure? Yes. Let's go with payroll. Let's just add it to an existing one. Okay, configuration. What do I want to call this app? MMS perf is fine. Which operating system do I want to go on? We'll just take the standard one. And now it's going to ask me, where are those configuration files? So we're going to take a look in the storage repository. It's going to pull back all the different folders. I think we've got the customer demographics one will do. It's going to come back and tell me what worker roles, sorry, the resolution of these screens is a little small, show me what roles are involved in this application. I have to pick the matching configuration file, and I can hit deploy.
So in that configuration file that Adam just uploaded, you specify in there, it's just an XML file. It says, here's the roles that are part of my application, here's what I want them called, and here's how many instances of each of those roles I want you to spin up initially. And then App Controller automatically shows you in the diagram. If you said 5 instances, it would spin out and say, hey, here's all 5 of those instances. And it just sucks that out of that config file. So you see what's going to happen when it actually spins up the app.
And I'm completely maxing out all of my Azure subscriptions right now. So the failure was that I've hit my capacity limit again. So good news, we've got the capacity that's kicking in. One thing I do want to show you before we come to the end, I'll open up some questions, is jump to the right options. Show you what was going on there. So when we were managing those applications, one thing I want to make sure that everyone understands is the difference between that Azure application and an application that's on-premise. They are different. They might be constructed of the same language, as in .NET, but they are different. In a virtual machine manager private cloud, it could be running on Hyper-V, VMware, or Xen Server. You have a .NET application that is could be running in Server at V, runs in a service template, and is deployed out in a templated fashion. In Windows Azure, we have that package and configuration file. There is no opportunity at this point in time to move an application from Windows Azure down to your private cloud and back again. Okay, the construct is slightly different. The characteristics are very, very similar, but they are 2 different applications. Okay, just to make that very clear. We've got the management we talked about. We've seen both of those coming together and getting that visibility across all of those clouds. Now, how do we connect? The way that this actually works is those Azure subscriptions that you can see on the right-hand side, and then we've got App Controller on premises that we're connected to. We have a public key that is stored out in Windows Azure, and in the Azure portal, you configure your public key, and then when you browse to that certificate in App Controller, that is the private key that matches that public key. All of the authentication goes via the API. It is all encrypted, it is all protected, and it basically does a handshake of PKI. The private key talks to the public key, makes sure that they match, make sure that the password's okay, and then it allows you to connect and do that delegation. So all of it is very secure. App Controller adds the additional layer of the read-only role, allowing you to do it through a nice Silverlight console. It's very dumbed down, if you will. It's very simplistic. But it allows you to delegate out the rights to do what Craig was doing in Visual Studio, or your developers are doing. It brings it down to an application owner layer where a non-technological person or an IT owner or an IT business person who is not a deep developer can take that handoff of the application, use a toolset like App Controller to simply create storage, upload it by copying and pasting things, and then deploy that application out with their configuration. We've made it incredibly simplistic to do that, and what we want to do is to show you, and the whole reason for running these sessions is to show you guys how to get in the middle of that, how to make your app owners and your developers work with you rather than bypassing you. And we don't want developers to be publishing straight to Azure. I mean, that's bypassing just about everybody in this room. It means that businesses are going straight out, they're deploying apps in an unfashioned way, there might not be monitoring associated with that, you don't know where your data is sitting, you've got to get some control back. Okay? And with System Center and the integration we've done with Windows Azure, the whole point is to get in the middle of that so you can get some control back. Question? Yes? I'll let Craig answer that.
So the Azure OS, there's a couple of ways to think about Azure OS. So when our technical fellow, technical fellow at Microsoft means really, really smart engineer guy who has been around a long time. The gentleman who sort of designed core pieces of the fabric, Mark Russinovich, you may know, he thinks about the whole fabric that sort of orchestrates all of this stuff as the Windows Azure OS. So that's the brains, that's HAL that runs. So that's in his brain OS. If you're thinking about the OS that's actually running on the instances of your virtual machines that are hosting your apps, that's something different.
You have the choice with deploying on Azure OS. Mm-hmm.
It is, so Windows Azure OS is Windows Server with some special goo on there to make it work inside the fabric, and that's all that it is. And the versioning, I mean, you're never really going to have the ability to take what is the actual Windows Azure OS that's running in the cloud and run that on-prem and test. That's where you're going to have a separate testing environment in the cloud to actually get that parity and do the side-by-side testing.
What about, I don't know if that was something you had, but there were 20 OSs you could choose from.
They're all date stamped. So what you were seeing was the version controlling as the operating system was updating. So if I'm not quite sure how the patching works, and Craig can talk to it more than I, but if you need to run a particular date version because something changed, then you can choose it. It's purely giving you the history of the updates.
So when Windows Azure does updates, because of security patches or what have you, it does that. It increments that, and then you'll see all of those in the list. You can turn that off so that you can say, I don't want, actually, we're running very well. We have a very fragile application. I don't want to introduce any risk whatsoever. You can actually turn that off so that you're not getting updates. Of course, then you are sort of introducing yourself to other kinds of risk if you're not getting those updates. But at least you know you'll have a stable platform and you won't have any sort of OS upgrades. So that is something that you can configure. Yes, sir.
Okay, so the question was, does App Controller allow you to connect to anything other than Windows Azure? So you would have seen in the keynote this morning, the very last thing that Ryan showed was connecting out to the service provider. That is coming with the update later on this year that will support Windows 8 and a few other things. So we gave you a peek. Today, App Controller 2012 connects to Windows Azure. I guess that's our timer to say hurry up. It connects to Windows Azure and Virtual Machine Manager. Those are the two connectors that we have today. Moving forward, you would have seen that the SPF, which stands for Service Provider Framework, we can connect to other clouds. Okay, so that is coming. We have a plan of record to broaden that out. So we gave you a sneak peek of what that looks like this morning.
I think we do have more time. I think the clock was just malfunctioning.
Oh,
so.
It just beeped at us to say hurry up, and we've actually got some time left. So any questions around all that? I know we went through very, very quickly, but we wanted to make sure that we got through the setup and got the app deployed. In the next session, we're going to show you how we monitor it with Operations Manager and do all the performance level stuff. Question? Yes. Yeah. I believe the question was the limits that are set on our subscriptions. That's done at the Windows Azure layer. That's to do with the subscriptions that we run.
So there's the ability to adjust that within App Controller, or you need to go into the
That's a good question.
Changing the limits of what you can do within an Azure subscription would need to be changed at the Azure subscription level.
Yeah. 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 Yeah, we all run subscription limits, and as Craig said, it's pretty much unlimited scalability. They don't want us as employees to suddenly go and soak up all the resources, so we are capped, which is what the limit you're seeing. So I'm going to clear some stuff out so we can do that.
But when you sign up for a Windows Azure subscription, you do say, I want this type of subscription, and there's some limits associated with that. And if you want to spin up 2,000 cores tomorrow night to crunch some financial data, but you've never done that before, you might need to call us and say, hey, I'm going to start needing to use 2,000 cores every night. That's some information we need to configure on your account to make sure that you're set up to do that. Because if you try to spin up 2,000 instances, I don't think it's going to let you.
No, not an App Controller today, no. You can't change that setting. It is at the Azure subscription layer. And the restrictions are there to prevent people getting the big bill that they unexpectedly created 2,000 instead of 200 or something along those lines. So we don't want you to be able to go and soak out a large amount of resource and then get a really big bill. We'd rather say, actually, you can go to this far, but if you want to go further, then that's fine, but just tell us so that it's okay, and you're going to be okay with the bill that you're going to get for that. The big number crunching is a good case study that we've got coming through. You can't, or building a data center with 10,000 virtual machines in it so you can crunch some numbers overnight is a really big investment that only runs for 4 hours every night. It's kind of it's a lot of hardware to buy. And so doing this kind of thing, being able to spin it out I'm showing you everything manually here as well. App Controller has a PowerShell provider. It has a management pack as well. So the ability for you to scale out based on performance rather than just manually saying, hey, I'd like 3 instances. I'm going to show you an Ops Manager how we do the monitoring, and you can have it run a monitor that says, well, if my capacity hits 80% and stays there for a period of time, then scale the app out. It doesn't need to be manual. I'm showing you what it looks like manually, so you've got control. But we're going to show you how the monitoring sort of comes through, and Craig's got a nice dodgy app that we've put up that's not behaving particularly well. It's a very dodgy app. So we're going to show how we can monitor that, how you can set service levels against the Windows Azure applications, report those in very rich dashboards. You saw in the keynote this morning the service level objective dashboard. I'm going to show you how to build those against Windows Azure as well as the one we did on-premise. So all of that's in part 2 after lunch.
So yeah, just, sir, yes, sir. Great question. So the question is, I don't want to configure everything ahead of time. I don't know what my traffic's going to be in the future. I want to be able to handle that when it happens in the right way. So there's a number of different ways to do that. One is having a dashboard configured where you can see that this is an issue, and then you go click increment those number of instances, and then watch your CPU usage, et cetera, fall. That's sort of the manual way, which means you have to be staring at your dashboard the whole time. Adam mentioned, and he's going to show you later, how to set up boundaries around the dashboard such that something can happen when you hit a certain threshold. It can run a PowerShell script that will scale your instance. If you're not using Operations Manager, there's other tools to do that. There's some code that you can implement that's put out by Microsoft Patterns and Practices that allows you to configure all the boundaries that you want, and you actually can run that code in a Windows Azure role, monitoring other Windows Azure roles, and then call that Service Management API to do the scaling when those thresholds are hit. So there's a few different ways to do it. The most manual, of course, is staring at the dashboard and waiting for it to spike, which probably is not the best, but some people want to actually have that level of granularity and control and say, I want to be the one that clicks add new instance when it's time to do that. I don't want to have the system doing this automatically and then have some surprises when it comes time to pay my bill at the end of the month, right?
I think the System Center approach to that is to use Operations Manager to see what's going on, and you would scale based on load. And because Operations Manager is doing it, if you wanted to have an approval route before you did it, you could do that as well. Hey, Ops Manager has noticed that your app's flatlining and has done it for the last 20 minutes. You might want to go do something about it. Ops Manager raises an alert, that turns into an incident in Service Manager, goes into an approval route. Are you okay with the bill? It looks like it'll be about this much if we scale it out for this long. Yes, I'm okay with it. Orchestrator, Ops Manager, whatever, goes out and runs the scale and moves it out. We're showing you simply the very manual way, but you could completely automate this so it just scaled in and out based on performance and load. And the good thing about the scale out with Azure is it scales back in again. As Ops Manager notices the load come back down, you might set a threshold that says, when I go over 80% utilization for 5 minutes, scale out. If it drops back down below 20, 30%, whatever, scale it back in again. Okay? Scale out, scale back in, backwards and forwards. And the Windows Azure applications, by definition and by default, along with the load balancing and so forth that Azure does, allow you to go in and out. Now, if you've got stateful information in your app, then you want to make sure that you've got a way of offloading that, but that's an internal application thing to be wary of. Scaling out is typically really easy. Scaling back in can be far more challenging. Hydrating, easy. Dehydrating, not always quite so easy. Cool. If there's any more questions?
So we would like to invite you back for part 2 after lunch if you're available, where we're going to get into that, more of the monitoring piece and Ops Manager and show you some of these things, and I think we'll be able to answer quite a few more questions on that front. And a couple other quick things. For those of you who are interested in understanding what the portal experience looks like for updating and managing applications outside of App Controller, I'm happy to show you that maybe as part of the second session or in the booth. The other thing is, if you want to get your hands on Windows Azure and just try it and just upload a silly app and just see how it works and what it is, you can do that for free. We have a 30-day free trial. It's on windowsazure.com. You can sign up, and I'd be happy to give you some sample apps that you can upload and push and play with. So if you want help getting set up or configured or need some sample apps to try to test out your Windows Azure subscription, please stop by the booth and we'll be happy to help you out and help you do that.
We also do in part 2, we're going to spend the time in Operations Manager with Windows Azure, but we've also got Vinay coming along and he's going to cover the monitoring of SQL Azure as well. Okay, so we released some new SQL Azure monitoring. Vinay's going to come out and close out the last 20 minutes of our session after lunch and show you how we do the SQL monitoring and what that looks like. And there's some really cool stuff in that as well. So even if you're using Windows Azure just for SQL storage, there's a lot you can do there. So please fill out your evaluations. You can win prizes. We'd love to hear what you thought, what you wanted to see. If it was good, tell us. If you wanted something else, tell us that as well. Loads of information online, just going through the standard stuff, mms-2010.com. And if you have any questions, those are Craig and I's contact details, our Twitter handles, as well as our email addresses. We're always happy to take questions. We will be at the event all week, and we'll be around the booth and so forth as well. So hope you enjoyed the session. Hope it was useful, and thank you very much.
Thanks.